What's up guys? So for today's video, me, Janrel, together with Ria, Ira, Ayan, Shane, and Paige, and my other group mates are here to be tackle of our output in General Biology 1, which is Electron Transportation System. But first, let me tell you what an electron transportation system is.
General Asap, let me interrupt you first. Before we're gonna proceed, let's ask this group of students about their opinion about the electron transportation system. Let's go. Hi, excuse me. Can I borrow some of your time? I would like to ask some question about electron transportation system.
Yeah, sure.
But first, I would like to ask your names formally.
Okay. My name is Ayan, and this is my friend Paige, and Rhea, and this is Ira.
And I am Shane D. Boris, and your interviewer for today. We're all set. Can we start? Then let's start. This question is for all of you. What is your own feelings about electron transportation system?
For me, the electron transportation system is a cycle where the electrons are being passed through places. I'm not really sure though.
How about you, Ayan? Ayan, right?
Yeah. So for me, the electron transport chain is a set of 4 protein complexes that link the redox of processes to create an electrochemical gradient that results in production of ATP in a process known as phosphorylation.
Thank you, Ayan.
For me, from the word electron transportation system, it means that the electrons are being transported from one phase to another.
Okay, thank you, Paige. And last, how about your opinion, Rhea?
For me, the electron transportation system is a process where the electrons are being transported from NADH to SADH complexes and electron transporters. Thank you.
And that's it. Thank you, everybody, for all of your opinions. Alright, that's all the question. Thank you, Ayan, Rhea, Ira, and Paige to lending us some time to answering this question. Let us give them a round of applause. And now it's time to reveal if their answer is correct or if it's right. Let me call on General Asaf to continue where he left us. Thank you.
Hi guys, I'm back. And again, with my dearly friend, Chris.
Hello.
With Paige. 2 people, her will be my substitute for today's video to discuss how the electron transportation system works. But first, let me continue what I started earlier.
In the inner mitochondrial membrane of the cell, it is all well started.
The system is composed of 4 complexes and 2 small diffusible electron carriers shuttling electrons between them. It started on the complex 1 and is named NADH dehydrogenase complex. From the word dehydrogenase, it removes hydrogen from the reduced form of the nicotinamide adenine dinucleotide. And it is called complex because it also contains flavin mononucleotide and iron sulfur compounds. It is called oxidoreductase because dehydrogenation is an example of oxidation-reduction reaction, from which 2 electrons pass through a series of iron sulfur centers to the iron sulfur protein in the matrix arm electron transfers from N to 2 to COQ, and the membrane arm forms QH2, which diffuses into the lipid bilayer.
The job of this complex is to receive electron from NADH and transport it further to the electron transport chain.
In the complex 1, the NADH is being dehydrogenated with the help of the electron. And in the complex 2, the FADH positive is the one being dehydrogenated. Complex 2 catalyzes the reduction of the COQ by electrons removed from succinate.
Succinate dehydrogenase, the only membrane-bound enzyme in the citric acid cycle. Although smaller and simpler than complex 1, the same as complex 1, it is called dehydrogenase because it removes hydrogen from the succinate and then oxidizes it to fumarate. It is called a complex because it contains iron sulfur cluster in addition to the succinate dehydrogenase, and it is equivalent to the FADH2 produced
By FAD within complex 2. FAD passes them to iron sulfur clusters, and then to coenzyme Q, similar to complex 1. However, no protons are translocated across the membrane in the complex 2. Therefore, less ATP is produced with this lactase, and also known as the Q-cytochrome C oxidase. The complex 3 couples the transfer of electrons from ubiquinol or QH2 to cytochrome C. The main job of this complex is to accept the electron that comes from the complex 1 and 2 and transport it to the cytochrome C, and then the cytochrome C then transports the electrons from the complex 3 to the complex 4 of the electron transport chain. In the final step of the respiratory chain, complex 4 carries electrons from cytochrome C to molecular oxygen, reducing it to H2O.
It has a heme and copper containing complex whose main job is to oxidize cytochrome C, which is to receive the electrons that have been gathered in the cytochrome C, and then uses those electrons for the reduction of the oxygen of the water. And that is why it is called the cytochrome C oxidase.
ATP synthase is an addition to the electron transportation system. It is where the hydrogen that is in the intermembrane space are being collected for the conversion of ADP into ATP. In shorter words, the hydrogen ions from the intermembrane space pass through the ATP synthase to help the conversion of ADP into ATP.
To sum it all up, electron transport chain starts from the complex 1 and 2, where the NADH and FADH2 are being dehydrogenated and turns into NAD and FAD, while the electron that comes from the complexes 1 and 2 are passed through the ubiquinone and proceeds to the complex 3 and goes to cytochrome C that transports to complex 4 to molecular oxygen, reducing it to H2O. Lastly, the ATP synthase, where the protons are collected to convert ADP into ATP.
At sa bawat minuto
Kaya makeup dye.
Then